Hello dear student, this is your Professor Lázaro Pino, and today we are having lecture number 5 exercises. Lewis representation, the octet and dual rules, the covalent compounds, single, double, and triple bonds, and ionic compounds. You remember that the valence electrons are those that are in the outermost shell, and that if we go to the periodic table, the number of the group corresponds with the number of valence electrons. Somebody known as Lewis made or proposed the dot representation. He represented the electrons, the valence electron, as dots. For example, hydrogen that has only one electron as lithium, sodium, potassium, rubidium, and cesium in group number 1, you represent the valence electron by a dot. Beryllium that have 2 electrons as magnesium, calcium, strontium, and barium, you represent the 2 valence electrons separated. In the case of boron and aluminum that are in group 3, you represent the 3 electrons this way. In carbon and silicon that has 4, then you represent 1 electron each side. But since nitrogen and phosphorus has 5 valence electrons, you begin pairing electrons, and so in oxygen, fluorine, and neon, all the noble gases, neon, argon, krypton, xenon, have 8 valence electrons surrounding the symbol of the atom. This is the dot representation or Lewis representation for the noble gases. And we say for elements that have 8 valence electrons that they get the octet rule. For helium, we speak about the duet rule because remember that in period 2, the atoms only can get as much as 2 electrons in the orbital 1s2. In order to be stable, the atoms have to follow 2 rules. The octet rule are for atoms that attempt to obtain 8 valence electrons, includes most of the atoms. And the dual rule is for those atoms that can get 2 electrons, 2 valence electrons as much. This is for hydrogen, lithium, and beryllium. Atoms that can achieve a stable octet or dual rule by forming ions or by sharing a valence electron. In this case of hydrogen and bromine, you can see that hydrogen needs 1 electron to get the duet rule and be stable, and bromine needs 1 electron to get 8 electrons and get the octet rule. What they do? They share these electrons, and then now hydrogen gets the octet rule, 2 electrons, and bromine gets the 8 electrons, and we say that gets the octet rule. In this compound, for example, hydrogen, every atom of hydrogen has 1 electron. Then what they do, they share these 2 electrons and both get the octet rule. That's why hydrogen is a diatomic molecule, because it's more stable as a molecule than in form of atom. Let's see what are the steps in order to represent a molecule. For binary molecules, for example, as hydrogen, we have the 2 symbols, one in front of the other. And we know that every atom has 1 valence electron. Then we have a total of 2 valence electrons. What we do? We represent these 2 valence electrons being shared by the 2 atoms. What are the two tests that we have to do in order to see if this structure represents correctly the hydrogen molecule? First thing, the number of dots that is equal to the number of valence electrons found in rule 2. Then let's see. Exactly. We have 2 valence electrons in the 2 atoms of hydrogen, and they are represented in the molecule. Then it passed the first test. Let's see the number 2. Every atom has the octet for electrons around it, or the duet rule. Well, in this case, they get the duet rule. Then it passed the second test. These are the two tests that you have to prove in order to say that the representation for the molecule is fine. Let's see for this compound. In this case, we have 2 atoms of fluorine. You represent the 2 symbols. You know that as you have 2 atoms and every atom has 7 valence electrons, you have a total of 14 valence electrons. Then you represent the 14 electrons, taking into account that between the 2 atoms there will be a pair of electrons. And now you count. You say, well, I have 2, 4, 6, 8, 10, 12, 14. Then I have a total of 14 valence electrons represented, and is the total of valence electrons that I have for the 2 atoms. Second, do they get the octet rule? Yes, these atoms get the octet rule, and these also get the octet rule. Then this representation is correct according with the Lewis representation. Let's see for HF. Well, we have the 2 symbols of the atoms. We know that fluorine has 7 valence electrons and hydrogen has 1. Then we have a total of 8 valence electrons. Then first, we put 2 electrons between the 2 atoms, and then we fill the rest of the electrons around fluorine. And let's see if they pass the test. Well, we have here represented 8 valence electrons. That's fine. And the other thing, fluorine get the octet rule and hydrogen get the duet rule. Then the structure that we represented is fine. Remember, the types of covalent bonds could be single bond, 2 atoms share a pair of electrons. Double bond, 2 atoms share 2 pairs of electrons, then 4 electrons. Triple bond is when 2 atoms share 3 pairs of electrons, then 6 electrons. Let's see. For example, oxygen has, every atom of oxygen has 6 valence electrons. Then 6 times 2 is 12 valence electrons. We first put a pair of electrons between the 2 atoms, and then we fill the rest of the 10 electrons around the atoms. Oh, but what happened? This atom has only 6 electrons around, then it doesn't get the octet rule. Then this is not good. The test failed, and this representation is not fine for oxygen. What about if we represent a double bond between the atoms? Oh, in this case, we have 12 electrons around the 2 atoms. That's fine. And every atom gets 8 electrons for itself. Then this representation is fine. Let's see in the case of nitrogen. Nitrogen has 5 valence electrons. As we have 2 atoms, we are going to have 10 valence electrons. If we put 2 electrons between the 2 atoms and we put the rest of the electrons around the atoms, we see that this atom will have only 4 electrons. That's not good. Then this representation is not fine. What about if we represent a double bond? Not yet, because then this atom has 2, 2, and 2, 6 electrons. Then this atom doesn't get the octet rule. Then this representation is wrong. What if we represent a triple bond? Oh yeah, now yes, because this atom has 8 electrons and this atom has 8 electrons. Then the triple bond between atoms of nitrogen is the best representation for the nitrogen molecule. For ternary molecules, more than 2 elements in each molecule, the atom with lowest electronegativity, and when we say electronegativity, by now are the elements that are more to the left, are less electronegative, are placed in the center of the molecule and then surrounding the rest of the atoms. In this case, phosphorus is to the left of chlorine. And then we represent pairs of electrons between the atoms, and we distribute the total of electrons in the 3 atoms around, and we get the Lewis representation. If every atom has 8 electrons around it, we say that they get the octet rule and the representation of the molecule is fine. In the case of CCl4, well, carbon is more to the left than chlorine. Then we represent it in the center of the molecule and surrounding the 4 chlorine. We distribute 2 electrons between every 2 atoms and the rest of the electrons around the molecule. And we observe that we have 32 valence electrons in this molecule, and every atom get the octet rule, as you can see here. Then this representation is fine. For ethane, well, we put 2 atoms of carbon in the center and 2 electrons being shared between the 2 atoms of carbon, and then we put the rest of the hydrogen around the carbons. In this case, 6 hydrogen, and between a carbon and each hydrogen we have 2 electrons. Now we observe that for every hydrogen we get the octet rule, the duet rules, and for every carbon we get the octet rule. Then, as we have the number of valence electrons represented, and we get the duet rule for hydrogen and the octet rule for every atom of carbon, we say that this molecule represents correctly the ethane. These are the instructions online, the strategy to draw Lewis structure for molecule. First, find the total number of valence electrons. Find the number of electrons needed to make the atoms happy. What does it mean? Octet rule or duet rule. Choose the central atom. Draw the skeletal structure and place the electron around the outside atoms. These are the instructions you are supposed to follow in order to draw the Lewis structure for all the molecules. For ions, it's different. When the first element is a metal like magnesium, sodium, and we have 2 make a different strategy. In this case, we have to represent